Okay, let's solve this now by using the backward substitution. So note, if Tn equals Tn minus 1 plus n, then by using the same formula but replacing n with n minus 1, I get Tn minus 1 equals Tn minus 1 minus 1, and minus 2, plus n minus 1. And again, replacing n with n minus 2, or using this formula and replacing n with n minus 1, whichever way you want to think about it. Maybe the original formula, but with n replaced with n minus 2. So that would be Tn minus 2 equals Tn minus 2 minus 1. So that's n minus 3 plus n minus 2. And you see what's happening here. You can say Tn minus 3 equals Tn minus 4 plus n minus 3. So now, if we start again with Tn equals Tn minus 1 plus n, take that up a little bit, and we can sub in this. So we get Tn minus 2 plus n minus 1 plus n. Or in other words, Tn minus 2 plus 2n minus 1. Now, if we sub in n minus 2, we will get T, so that's this one here, Tn minus 3 plus n minus 2 plus 2n minus 1. So that would be Tn minus 3 plus 3n minus 3. I think that's fine. Although perhaps I don't want to put them together just yet, because I think I can see something that's going to happen maybe on the next one. One more. So we'll get Tn minus 4 plus n minus 3 plus 3n minus 1 minus 2. So we'll have Tn minus 4 plus 4n minus 1 minus 2 minus 3. Yeah. So you can see what's happening. By repeatedly substituting in, we can arrive at this form for the Tn formula. Tn minus some constant plus that same constant times n minus 1 plus 2 plus 3. But we stop at k minus 1. One value before this constant here. Now we can continue doing this until n minus k equals 1, which by the way means that k equals n minus 1. If we continue this subbing in process until n minus k gets us to 1, the first term, then we'll have T1 plus k, which is n minus 1, times n, minus this sum here, which is k minus 1 over 2 times k. Oh, I'm sorry. I should be really saying what n is. Or sorry, what k is. K is... Oh yeah, that is what I said, isn't it? Silly me. N minus 1. So this is the sum up until k minus 1. But maybe I'll replace the k minus 1 n minus 1. I'm not sure if I want to do that just yet. I think I'll do it in a second line. So I might have confused you if you were listening to me. Let me recap what I'm doing. I'm going all the way until n minus k is 1. So this becomes T1 plus kn minus the sum up until k minus 1. So that T1 is 1. So that's 1 plus kn. And I can replace the k if I want to do an n minus 1. And I can definitely replace this with the formula. So that's a half k minus 1 and then k Because remember, the formula for the sum of the natural numbers is n over 2, n plus 1. So this will be 1 plus n minus 1 times n minus a half. K minus 1 is n, and k is n minus 1. That's 1 plus, and it's one of these minus a half of them. So that's a half n minus 1. So that's 1 plus a half n squared minus a half n. Now, I feel like that's wrong. I feel like I've made a mistake somewhere. Some silly little Stephen mistake. It does check out. If I was to calculate the terms here, n is 1, we get 1, which is the first term. If n is 2, we get 2 squared is 4, 4 over 2 is 2, 2 minus 1 is 1, plus 1 is 2. Which I don't think is right. So I think I have made a little mistake towards the end. Let me try and fix that up. Maybe I tried to be too fancy pants. Maybe it's with my sum. N minus k equals 1. So that means k equals n minus 1. That's right. T1 is 1. And that k matches that. And then the sum is 1 less. And that's a half k minus 1k. That's a half k minus, oh, k minus 1 isn't n. There's my silly little mistake. K minus 1 is n minus 2. There we go. So that's 1 plus n squared minus n minus a half n squared. N by n is n squared. Minus 3 over 2n minus 1. So the 1's cancel. That's n squared minus a half n squared. So that's a half n squared. And then, that's a plus. Minus n plus 3 over 2n. That's minus a half n. No, plus a half n. So that's equal to over 2 n and n plus 1. Yeah, now it's correct. Okay, sorry about the slight error near the end, but hopefully that's all clear now.